Alright, so for this video I'm going to do pages 15, 16, and 17. They all kind of go together. So 15 starts with looking at functions being added, multiplied, subtracted, or divided. So at the top here you have these operations. They're pretty straightforward. I'm just going to fill them out though here because it's going to help you answer the rest of the questions. So it's as you would think. Whoa. F plus g of x equals f of x plus g of x, where f of x and g of x are two different functions here. Okay? F minus g of x, as you would think, f of x minus g of x. And then this same process for multiplication and division. Okay, so these are pretty straightforward operations. There is one more thing on this page called compositions of functions. So it's where you have that like open circle. It looks like it says fog, but it's f, that little circle, g of x. So that means this is the composition of two functions. So if you see this f of g of x, this looks like. And I'll do an example to show you what this looks like. These are pretty straightforward. So for 5, 6, 7, 8, 9, you're just going to be using these operations here. And it gives you an a of x, a b of x, a c of x, and a d of x. So for that first one, you would just do the d of x minus the a of x, and then you're just really simplifying an expression there. You're still going to have variables. In the second section, you're doing the same thing, but it now gives you, like for number 11, it says b plus d of negative 2. So you're going to use this. You're going to do b of x plus d of x. Simplify that all out, and then plug in a negative 2 for the x values. So for 5 through 10, you're going to have x values left over. It's just simplifying expressions. But for the rest of the page, you have a value to plug in. So I want to show you, though, like for number 10, how this composition works. So number 10 says, A composed with b of x. So using this, I can rewrite this as a of b of x. So first we know a of x equals x squared minus 9x plus 20. And b of x equals 1 minus 5x. So we're just going to substitute in where we can, one step at a time. So I'm going to take this. So I have a of whatever b of x is. I can plug that in. I can substitute that in. It says b of x is 1 minus 5x. Okay, so I'm going to do this. So now I have a of 1 minus 5x. So look, if I had just a of 2, and I was using this, but now I have a of 2, we would just plug in a 2 for every x value, right? That's familiar. This is the same process, it's just a little bit more messy. It's basically just telling me that this is going to be substituted in for every x value, just like this 2 would have been. In these parentheses here, this is telling me that 1 minus 5x is what I'm going to substitute in for every x in the a function. Okay, so this is going to look like 1 minus 5x squared minus 9 times 1 minus 5x, okay, plus 20. And then you just simplify that out. Okay? So that's what composition looks like. You start from the inside and work outside. So I replaced my b of x with what I knew it was. And then I solved this like I would a normal substitution problem. Okay, so that's number 10. And then for number 12, you're going to do the composition again with D and C. But then it gives you a numerical value there. You're going to plug in a 7. Once you get all your x's simplified, you'll plug in a 7 there for number 12. But for number 10, you're leaving it in terms of x. Okay? So, on to page 16. So now we're talking about inverses of functions. So, it seems really switching gears here, but it does come back and relate to what we just talked about. So first, it's talking about finding the inverse of a function. So there are many different ways to interpret this and to do this. I'm just going to tell you the way that I've always done it. If not, you can Google all the different ways to find an inverse of a function. So it says find the inverse, so we have f of x equals 2x minus 7. And it wants to know the inverse of that function. And then it wants you to graph both of them. Okay? So we know that we can rewrite this as y equals 2x minus 7. And that's comfortable for us. Okay, so how I find the inverse, what you do here is you swap your x and your y. Okay? So we have x equals 2y minus 7. I just swapped my two variables. Okay, so you take your new equation you have here, solve for y. Okay, so I have x plus 7 equals 2y divided by 2 divided by 2. Y equals x plus 7 over 2. The answer once you solve for y is the inverse of the original function. Okay, so you just swap your variables and then solve for y. And you can graph those two on that graph right there to see the relationship between a function and its inverse. So in that little middle section, a little rule, it says two functions, f and g, are inverse functions if and only if. And so now this notation should look familiar to you. F of g of x equals x. So this is like composition. So that would just mean you would substitute in whatever g of x is, and then replace all of this inside for the x's in the f function. And, okay, that's important. Let's go both ways. And g of f of x equals x. And I know this looks funny, but it works. So for 15 through 16, I want you to determine whether they're inverse functions of each other. So you're going to test both of these things. Do f of g of x and see if you get x. Then g of f of x and see if you get x. Both of those have to be true. I actually did number 15. And you can see, if you want to like pause this or take a screenshot of it, you can see both of these equaled x. So they are inverses of each other. And that's all it wants you to do for 15 through 17. Okay. Page 17. So this is switching gears a little bit. So it's talking about direct, inverse, and joint variation. All right. So, up at the top here, so direct variation, I'm going to write this and then I'm going to explain it. So this is the equation for direct variation. Y equals kx, where k is a constant, any constant. So this, how you could speak this in a sentence, y varies directly with x. As opposed to, I'm going to jump over to inverse variation because it's like kind of the opposite. We have y equals k over x. This is my constant. And how you would speak what this is doing right here. Y varies inversely with x. Okay? So it's just explaining how these two variables are interacting with each other. You can see here, anything times x, so if you have y and x, in this situation, they're going to vary directly. Whatever happens to x, if it's being multiplied by 2 or it's being multiplied by 1/2, y is going to vary in the exact same way because it's the equation. Whereas here it's kind of opposite. Y varies inversely because we have this division here. So for joint variation, we're now talking about not only x and y, but x, y, and z. So we have 3 variables. So this is direct. This is inverse. And then this is joint. So this looks like y equals k, still my constant, xz. So this means that y varies jointly with x and z. So this k is always just the constant, representing that you can plug anything in for that k, and it's going to show that relationship between x and y, or x, y, and z. So for 18 through 20, you are to determine whether the equation represents direct, joint, or inverse. So none of these are really in a form that's going to be helpful for us. So for all of these, you see how all these are y equals? You're going to have to change them to y equals and see what form it's in. So, and it says identify the constant. So I just did number 19. So I solved for y, and I got y equals 3/2 times x. Okay, well that looks like this one, right? Some constant, some number times x. It wasn't some constant over x, and I don't have 3 different variables here. So it's a direct variation, and my constant is at 3/2. So you're going to solve for y, and then see which one you're dealing with here. Okay, so 21 through 24 touches on how I was like saying this is how I would speak this scenario in like a sentence. Like for 21, D varies directly with R. Well, it says directly, so we know it's going to look like this. It's just a matter of knowing where to put your variables. But it's pretty straightforward. So if this is y varies directly with x, D varies directly with R. So you have that constant, and you have to make sure your D is the one out front here. So it takes you through 24. So for the bottom half here, it says to use the variation type to find the missing value. I'm gonna work out number 25. Okay, so it says M varies jointly with N and P. I'm gonna go ahead and write up exactly what that looks like based on what it's telling me. So it varies jointly. So I have M varies jointly with N and P. This is my constant. Okay, so it says M is 120 when N is 2.5 and P is 2. Okay, and then it says find M when N is 3 and P is 2. So, first in this equation, we're going to solve for this k value. And then we're going to put that k value into here to solve for M. Okay, so that's the algebra it wants you to do for these bottom half equations here. You'll just use the equations at the top to figure out what variables you need. Alright, and then it takes you through another little quiz here. Little 2-page quiz, which I think we touched on everything here. But if not, just email me and I can help you with any question. And then page 20 is like the last one in this packet, and then you have another quiz, and then that'll be it. So I'm going to do this page in a new video.